All right, so we're talking about partial pressures. So with Dalton's law of partial pressures, essentially all it's saying is that the total pressure of a system is equal to the sum of all the pressures in that system. So if we, so what is the total pressure in a balloon filled with air? If the pressure of oxygen is 170 millimeters of mercury and the pressure of nitrogen is 620 millimeters of mercury. So that total pressure is just going to be the pressure of oxygen plus the pressure of nitrogen. So we have 170 plus 620, and that's going to give us 790 millimeters of mercury. Now, if we try something a little bit more complicated, where in the second balloon, the total pressure is 1.3 atmospheres. What is the pressure of oxygen in millimeters of mercury if the pressure of nitrogen is 720 millimeters of mercury? So for this one, it's a little tricky because we have to convert 1.3 atmospheres into millimeters of mercury. So if you remember from the other day, 1 atmosphere is equal to 760 millimeters of mercury. Remember those things from your reference table. So if you take 1.3 atmospheres and multiply by 760, you will get 988 millimeters of mercury. So that's your total pressure. And remember, we're trying to find the pressure of oxygen. So we know that nitrogen is 720. So if we take 988 minus 720, that's going to give us 268. So the total pressure, the pressure of oxygen is 268 millimeters of mercury. So a container has a total pressure of 846 torrs and contains carbon dioxide gas and nitrogen gas. What is the pressure of carbon dioxide in kilopascals if the pressure of nitrogen is 50 kilopascals? So go ahead and take a second to work this out, because first you have to convert 846 torrs. So pause the video here and work it out. So your pressure of carbon dioxide is 63 kilopascals. All right, so moving on to the ideal gas law, that's the equation PV equals nRT. This is on your reference table, where P is going to be your pressure, V is your volume, N is your number of moles, R is your gas constant, and T is your temperature. Remember, temperature is always going to be in Kelvin when we're dealing with gases. So your volume must always be in liters. If it's given to you in milliliters, you need to convert it to liters. So there's 3 different R's. You choose the R based off of what units your pressure is given to you in. So if your pressure is given to you in atmospheres, you'll choose the first one, kilopascals and millimeters of mercury. You do not need to memorize these because these are provided to you on your reference table. So let's do a problem. So how many moles of air are there in a 2-liter bottle at 19 degrees Celsius and 747 millimeters of mercury? So the very first thing we have to do, we have to choose our correct R. So we're going to choose 62.4 as our R. And then we need to make sure that we convert Celsius to Kelvin. So we have to turn 19 degrees Celsius into Kelvin. So that is going to be 292 Kelvin. And our volume is good. So let's go ahead and plug everything in. And we're solving for N. So our N is going to be 0.082 moles. Now let's move on to another one. What is the pressure in atmosphere exerted by a balloon of 1.8 grams of hydrogen gas in a 4.3 liter balloon at 27 degrees Celsius? So let's go ahead and make sure everything's in the right. We choose our first R, which is going to be 0.0821 because our pressure is in atmospheres. And then we have to convert that temperature into Kelvin. So our temperature is going to be 300 Kelvin. And now we need to figure out our N. So they gave us grams, which is 1.8 grams. So we need to convert that into moles, turn it into moles. So 1.8 grams is going to be 0.9 moles of hydrogen. Notice we use 2 because it's 2 grams because it's an H2, not just an H. And then once you plug all of that in, our P is going to be 5.82 atmospheres. And so that's it. We're going to stop there. What happened to my recording?